Understanding the science behind breathing involves exploring the physiological processes by which the body takes in oxygen and expels carbon dioxide. Purpose of breathing. Breathing, or respiration, is the process of inhaling oxygen-rich air into the lungs and exhaling carbon dioxide-rich air out of the body. It serves to exchange gases necessary for cellular function and remove metabolic waste. Mechanism of breathing. Breathing is driven by the respiratory system, which includes the diaphragm and intercostal muscles. Inhalation occurs when these muscles contract, expanding the chest cavity and lowering air pressure in the lungs, allowing air to rush in. Exhalation involves relaxation of these muscles, causing the chest cavity to contract and expel air. Gas exchange in the lungs. Upon inhalation, oxygen from the air diffuses into tiny air sacs, alveoli, in the lungs. Oxygen then enters nearby capillaries, binding to hemoglobin in red blood cells for transport throughout the body. Simultaneously, carbon dioxide, a waste product of cellular metabolism, diffuses from the blood into the alveoli to be exhaled. Control by the respiratory center. Breathing is regulated by the respiratory center located in the brainstem, which receives signals from chemoreceptors monitoring blood gas levels, oxygen, carbon dioxide, pH, and adjusts breathing rate and depth accordingly. Increased carbon dioxide levels or decreased oxygen levels trigger the brainstem to increase breathing to restore balance. Types of breathing. Breathing can be voluntary or involuntary. Most of the time, it occurs involuntarily through automatic control by the brainstem. However, voluntary control allows us to consciously modify breathing patterns, such as during speech or singing. Respiratory disorders and conditions. Disorders such as asthma, chronic obstructive pulmonary disease, COPD, and respiratory infections can impair lung function and affect breathing efficiency. Treatment may involve medications, inhalers, oxygen therapy, or pulmonary rehabilitation. Exercise and breathing. During physical activity, breathing rate and depth increase to meet oxygen demands of active muscles. This is facilitated by the sympathetic nervous system, which enhances lung function and oxygen delivery to tissues. Developmental and aging effects. Lung capacity and respiratory function vary with age and health status. Lung development begins before birth and continues through childhood. Aging may lead to reduced lung elasticity and respiratory muscle strength, affecting breathing efficiency. Breathing techniques and benefits. Techniques such as diaphragmatic breathing, deep breathing, or pursed lip breathing can promote relaxation, reduce stress, and improve oxygenation. These techniques are often used in yoga, meditation, and respiratory therapy. Conclusion. Breathing is a fundamental physiological process essential for life, enabling gas exchange that supports cellular metabolism and maintains homeostasis. Understanding its scientific basis helps in appreciating its role in health, wellness, and adaptive responses to environmental and physiological changes. This structured overview provides insights into the science behind breathing, encompassing its mechanisms, control systems, adaptations, and clinical implications for respiratory health and well-being.